Hello and welcome to this case study based on linear regression model. In this section, we will be focusing on the data set that have one independent variable and one dependent variable which will fall under the category of simple linear regression. So this data set describes the auto insurance claim files in Sweden in thousands of Swedish kronor for geographical regions. This dataset has two columns. The dependent variable is the number of claims and the independent variable is the total payment. That is the total payment that is likely to be paid based on the number of claim files. Our problem statement involves predicting the total payment to be paid given the number of claims in Sweden for data collected over some time. Let's get started. So firstly, we need to import all the libraries NumPy, Pandas, Matplotlib, preprocessing, train test split, linear regression, and accuracy and error related modules. Once I'm done with that, I need to read the data which is stored in the CSV format. So this is the data set. I have uploaded it in the Google Colab. While reading the data, you must mention the location of the data where the data set is stored. Okay, so I'll just hit this three dots and copy this path and I'll proceed with my data reading. So this is the variable df equal to pd.readCSV, and here I'll quickly paste the path of it. Now the data set has been loaded up. We can examine the rows and columns of the data set by printing the head of the data frame using df.head method. So it will just display first 5 rows of the data set. If you want to proceed with the more, you can give the 10, 20, however amount you want to see the number of rows. Okay. Next, we are going to analyze the data by looking at the data types. For this, we have a method that is df.dtypes, and it will show us the data type used in each column. So number of claims, it's integer, and payment is float. In case, you can use describe function also to understand more about the data. So that would be df.describe. So here it will give you all the statistics related things like mean, median, standard deviation, all of these using describe method. Okay. Next, we want to understand, since we want to understand more on the data, we'll just create a scatter plot to see how the distribution goes around. We'll create a scatter plot to find out the distribution of the data, the relationship between column 1 and column 2. So for this reason, what I'll do is in X, I will have my number of claims stored. This is how it goes. And similarly, I'll be doing it for Y. Once I'm done with that, I will take help of Matplotlib to plot it. So the function is plt.scatter, and here I'll just give my X and Y respectively, X comma Y. And then I'll just label it plt.xLabel. However you want to label it, just proceed. So in X we have this number of claims. So I'll just write that number of claims, and plt.ylabel is my total payment. Okay, this is done. We need to have a title also, plt.title, sample scatter plot for claims versus payment. plt.show. Okay, something went wrong here. I'll just fix it. Okay, it should be df. That is the mistake. Yeah. Now this is how the distribution goes around. Okay. According to the X labels, we have the plots being generated. Now X and Y have been separated as independent and dependent variables, and I have stored in them in X and Y. We have done this because the model will need to know as to which is the target variable and which is the dependent variables. Apart from this, scatter plot will also use the standardized function to normalize the column values to bring them up into one scale. So for this reason, I'll just proceed with, I'll just give a variable name, standard, okay, stdx equal to pre-processing dot scale x for x feature, and same I would be doing it for y feature. So this portion is done. Next, we'll have to use the train test split function uh, to split our data into training and test data set. So the test size would be 0.25, which indicates 25% of the data will be treated as test data and the rest of it as training data. Next, I'll just quickly do it. So I would have x train, x test, y train, y test. I'll pass my stdx, stdy, and test size, which means 25%. And I would have a random state, which would be 42. This random state is a seed used by random generator to pick the observations that will fall under the test and training data sets. So I'll just quickly run it with no errors. We need to reshape next. So we need to reshape the data when it comes to simple linear regression, because there is one dependent and one independent variable, whereas model.fit and model.predict, which we would be utilizing later, those two function always expects a 2D array. So hence the reason we need to just quickly do reshaping. So x train equal to x train dot reshape. Same goes for y train. And I would have x test. Now we will use linear regression functions from sklearn library to initialize our model. So regression model equal to, let's create an instance, linear regression. After this, we will fit the training data into the model and then predict the results using fit model. So after that, we need to fit the data. So regression model dot fit I would be using, fit method, and here I'll pass my x train, y train, x train, y train, and I need to predict it. So I'll just keep this variable y predicted equal to regression model dot predict x test, because that is what we need, which needs to be predicted. Okay, so here is the error. and done. Okay, so let's see how y predicted looks like. It should be D. This is what we have in the array. You can check with what you have in the original versus predicted. You can check that. And in order to be more good, we need to evaluate the built model using some accuracy parameters, that is root mean squared error and r squared. Okay, so as we know from linear equation, we have y equal to mx plus c. We also need to find and print the values of the slope and intercept parameters, which are the deciding parameters in the equation of the line. So I'll just evaluate the model. I would be finding out my RMSE and R squared. So this would be mean squared error. And in this I would be passing my y test and y predicted. Same parameters would be there for my R square. So it would be this variable. And the method is this one. Once I'm done with that, I will just have a look on each of these values, which would be this one. It would be somewhere like this and this. Okay, so this is what I am getting as of now. So what is this R squared? R squared, also known as coefficient of determination. It is the percentage of variation in the target variable that is explained by the regression model. Usually the higher R2 score would be the better your model performance as compared to the model with lower R squared. R squared score for your data set. At the same point of the time, it is also essential to understand that not all the models have a high R squared score. Regression models with low R squared scores can be also great models if the coefficient are statistically significant. So as of now, this is what we have, what we are seeing here. Here in this case, it is 0.84, which typically means success rate of 84%. That means it explains the variations in the data set with a success rate of 84%. And root mean square error, RMSC, is also relatively low, which shows that most of the data points are lying nearby our linear regression line. We also have to check the slope and intercept. For that, I'll just use a print and I'll just write in this way. So the method is regression model dot single f. This is the slope. Okay. This is what we have. Okay. Okay, this should not be there. And same would be for my intercept. So here the value would be changed to intercept. Let me just quickly run from the scratch to see the final values. Okay, So this is what we are having as of now. This case study at last aims to give an idea of how to look at various machine learning problems with different perspectives. So real-time data sets might be much more extensive than this data set where we have dealt with only two of the columns. Uh, but in case when you go to solve some complex, when you're going to work on some complex data set, there you will have more n number of features to work with. So that's all for the day. I hope you enjoyed this whole course. See you in the next session.